going to talk about these problems and identify their mistakes, okay? So we're going to identify the mistakes in these problems. So for number 3 here, as we are solving these questions, what was one mistake here on this problem? Okay, who did number 3? Okay, Rachel, help me out. And then Ian, oh, sorry, you did number 3.
So they subtracted 3 from negative 18 and got negative 15, but they should have gotten negative 20.
Yes, so they added the negative 18 and the negative 3 incorrectly, right? So they added, I don't know who they is, negative 18 and negative 3 incorrectly. Oh man, that's not going to fit. Okay. Incorrectly. So if we do this correctly, we should say, okay, x over 6 plus 3 is equal to negative 18. So what is the correct when we add it? What is going to be correct there? So x over 6 is equal to negative 21. You could have also said they subtracted 3 incorrectly from negative 18. So now that we have this, Ian, what are we going to do? How do we find the actual right answer? We don't know what x is equal to. Multiply both sides by 6. So my x is going to be equal to negative 126. Okay? So I guess if I was going to highlight the mistake, I would highlight it right here, right? Negative 18 minus 3 is not negative 15, right? It is negative 21. All right? You guys feel pretty good about that? Okay. For number 4, who did number 4 for me? Okay, yes, Rika, can you help me out?
Okay, so the first mistake that I saw was they didn't use inverse operation.
Yep.
So
They added 4 instead of subtracting 4, so I'm going to highlight that one for us, okay? That was wrong.
And where it says negative 2 plus 4, it's supposed to end up being negative 6.
Ooh.
The 4 should have been negative.
So this should have been a negative 6 over here. Also, yeah, but so it's kind of all the same mistake, right? They added 4 instead of subtracting 4. But what happened here? What was another mistake that we found? Did anyone else find a mistake? Another mistake? Yes. What's up? They forgot to bring down the negative. That's 4 minus 2x. So they didn't bring down that negative. They left it off. And that also affected how they divided, right? Because then they should have divided by negative 2. Also, is 2 divided by 2 equal to 6? No, they made like a lot of mistakes, okay? So you would describe them. They didn't use inverse operations. They forgot to bring down the negative. Then they didn't divide by the negative. And they also divided incorrectly. So these poor guys, man, they're really struggling, okay? So if we are going to do this properly, we would say 4 minus 2x is equal to negative 2. And then we would go ahead and do our inverse operation here and fix that to be negative 4. So just like Rika was saying, we would do negative 2 minus 4 would give us negative 6, right? And then here, now we divide by negative 2. So my x is equal to negative 6 divided by negative 2 is a positive 3. Okay? So on your homework today, you will have 3 problems where you have to explain it in sentences and then do it correctly in this last box. I did it all in one box just so you could see it up here on the board. But you will have to explain it in sentences and then do it correctly, okay? So that's going to be part of your homework today. But before we do that, we're actually going to do we're going to teach a new concept, okay? So, because this is also going to be part of your homework. So this is how it's super important, guys, that when we make mistakes, we look at them and we figure out what we were thinking so that we don't make those same mistakes. I will tell you, one of the most common mistakes that people make when they're solving equations, they're moving too fast and they forget to do the inverse operation. Okay, they add 4 here instead of subtracting 4. That's super common. Okay, and not just on these problems, but in real life. That's something that students tend to struggle with. So what I want you guys to do is go ahead and take out a piece of paper, and we are going to be taking some notes today. And today we are going to be talking about literal equations. Okay? And we are dealing with Unit 1, Day 5. And this is 8:25. Okay? Unit 1, Day 5. All right, guys. So, when I say the word literal, what do you think a literal equation is going to have? Words. Okay? Basically, it's a lot of letters that represent words. Okay? So, a literal equation is any equation where the variables represent unknown values. And the difference with literal equation is there's often multiple variables. Okay? So this becomes really helpful when we are doing things in, when you're solving things in chemistry or physics or other subjects, okay, where you have a bunch of formulas, or geometry. We do a bunch of formulas when you get to geometry. So it's any equation where variables represent unknown values. So one that you guys are probably pretty familiar with is the area of a rectangle, right? And what is the area? What's the formula for the area of a rectangle? It is area equals length times width. Okay? I'm going to say area equals length times width. Okay? But it is annoying to write out those words every time. So we create these variables that represent those words. Does that make sense, guys? Okay? So that's a pretty common one that you guys have already been familiar with that. Another one that is good is that we can say is velocity, okay? The velocity formula. Okay? The velocity, the formula for velocity is distance traveled over a period of time. So how I would write that as a formula, I'm going to go over here. I'm going to say V is equal to D over T. Okay? So guys, the words for that is that my velocity is equal to my distance traveled over a period of time. Okay? So for example, oh, you can't see that, my bad. So for example, guys, like your velocity is also your speed, right? That's kind of a fancy word, fancy physics word for speed. So miles per hour, okay? Meters per second, all that kind of stuff, okay? So that's how you can find your velocity. However, it's super annoying to have to write that out, that relationship, right, over and over again. We don't want to say, oh, the velocity of an object is the distance it's traveled over a certain period of time. We don't want to say that every time. So we create these formulas that are kind of our shortcuts for that. You will do a lot of different things for, you will have there's a ton of formulas that we work with in that. In not just math, but in other subjects, especially your sciences. Okay? And the beauty of these is that you can manipulate or change. Why does this even matter? Well, it matters because we can manipulate or change these equations to represent another variable. That's not a period. Ignore that. Sorry. In the equation. So we can manipulate or change these equations to represent another variable in that equation. Okay? So if we're looking for the area equals length times width is a great equation. But if we're not looking for the area, let's talk about some examples here. For example 1, let's see. We are going to use our area formula, but instead of area equals length times width, I want you to solve for W. I want to find out what the width is, not what the area is. Do we have W equals right now? We don't. So guys, what we do is we take our equation, area equals length times width, and we are going to solve it for W. The biggest difference here is your answer is not going to be a nice even number. Your answer is going to have letters in your answer. Does that make sense, y'all? Because we don't know what the area is. We don't know what the length is. Okay? So right now, as you change your formulas, your answers is going to be other letters. So I want you to think about it just like we solve an equation. Like if we were solving for x, you want to get that W by itself. So guys, in literal equations, I like to circle the one that I'm trying to find so that I don't lose track of it, okay? This one is a little more simple, so you probably won't lose track of it. But as we get to more complicated formulas, sometimes it gets a little more complicated. So if I want to get the W by itself, how do I get rid or how do I cancel out this L? Divide. Exactly right. So if I divide this side by my L, that's going to cancel. If I divide, but whatever you do to one side, you got to do to the other. So now my area over my length is equal to my W. So guys, if you were doing a formula where you needed to find the width, you would just be able to have that area over length. Okay? All you had to do was memorize this one formula, and then you could change it around to find the one that you need. Does that make sense? Rather than memorizing 3 separate formulas for your areas and your width and your length. So we just did solving for W. Now, I want you guys to solve for L. Okay? We're going to try to solve for L now. So we're going to do, this is going to look very similar because it's L times W. So let's check this out. If we want to solve for our L, we want to keep this one by itself. How are we going to get rid of that W? Divide it. Because L, we do that inverse operation. So we divide it. So A over W is equal to L. Okay? Y'all feel okay with that? Now, some of you guys are like, Ms. Humanek, why are we doing this? This is really easy to figure out because it's just 3 things. Well, yes. But guys, some of the formulas we're going to be working with are a lot more complicated. And when we have to solve for that variable, I want to start with something easy. This one, you just had to do one little step. Okay? But sometimes we got to do more than one step. Let's look at example 2 here. Okay? So example 2, I'm going to draw a little line. We are going to deal with our velocity. Okay? So we're dealing with our velocity formula. We got d over t. So remember, this is velocity. Someone was like, that's not volume. And I was like, no, it's not volume. Volume is not distance over time. That's velocity. Okay? So first, we are going to solve for d. Whoops. We are going to solve for the d. Okay? So what I'm going to do is I'm going to say, all right, well, v is equal to d times t. So what do I need to do to get my d by itself? Ooh, very good. Okay? We want to get that d by itself. So I heard someone say, right now the d is divided by the t. So we need to multiply by the t. Y'all feel good about that? But whatever you do to one side, you got to do to both sides. So we're left with TV is equal to D. All right? So that is how we would solve for D. Now, does it matter if I have TV equals D or D equals TV? No. Okay? I just solved it the way it came out, and I just left my variable on the right side. But if you wanted to trade them around, you could. Okay? Now over here, I want us to solve. Let's see here. Now, I want you to solve for t. Okay? This one's going to be a little more complicated. We have our v is equal to d over t. Okay? So right now, the t is in our denominator. So guys, if I was going to solve for t, we need to get it out of the denominator. So we are actually going to start this one the same way we did this guy. Okay? So let's check it out. We're going to multiply this side by t so we can get it out of the denominator. Okay? You can only do that when the t is not equal to 0, which we're assuming the time is not 0. Okay? So we have TV is equal to D. Now, remember, what do we want to get alone? The t. So what do I need to do now? Divide by the v. So my final answer is going to be t is equal to the distance divided by the velocity. All right? Are you guys feeling okay? I want to do one more example with you guys with a formula. Okay? And then you guys are going to get to practice this on your homework. Okay. So, can I move on? Are you guys good? Awesome. Okay. So now we're going to jump up here to our second page. Okay. For our second page here, I want you guys to find our example 3. We're going to be talking about the circumference. Okay? The circumference of a circle. Okay? I guess we have to write that. Does anyone know what the formula is for the circumference of a circle? Off the top of their head? Okay, it is C is equal to 2 pi r. Now guys, here's the thing about pi. It's a symbol, but it represents an irrational number, right? It's like 3.14159, the decimals go on forever and ever and ever and ever and ever. Okay? So we leave it as pi, but it's kind of like a number. Okay? You treat pi like a number. Okay? You move it around like a number. You treat it like a number. Okay? So in this particular problem, I want you guys to solve for r. Well, what does r represent again, y'all? Yes. That's your radius. So your circumference is equal to 2 pi r. It's equal to 2 pi times the radius. So if we want to solve for our r, I'm going to circle this guy. How do we get the r by itself? What do? Right now the r is times 2 pi, so what do we need to divide it by? Yeah, we divide it by 2 pi. If we divide both sides by 2 pi, then we're left with c divided by 2 pi is equal to r's, is equal to my radius there. Okay? And that is just how we solve for r. Now here's the thing, guys. Sometimes with literal equations, it's frustrating because you're like, there's supposed to be an answer. There's supposed to be a number. But there's not always going to be a number. Okay? So when I ask you to solve for a certain variable, if there are multiple variables in the problem, if I ask you to solve for r and there's another letter, then your answer is going to have letters in it. Okay? On all of the problems that we've been doing, on these examples, right? When we were solving for x, what you notice about these is x is the only variable. Is there any other letter in this problem? So that means when you solve for it, you get an actual number. Okay? Up here, we solve for y. Were there any other letters in that problem? No. So we could actually get a value for your y. All right? So on these guys, when you have multiple variables, you won't always get a, your answer is going to have variables in it. Okay? So we use this a ton. We use this concept a ton when we are solving for y. Okay? We use this a bunch when we're solving for y with our linear equations. All right? We do this when we have something called, y'all actually learned this previously. We're going to be doing it a little bit. But you guys have worked with the slope-intercept form, right? Our slope-intercept form of an equation is y equals mx plus b, okay? And I'm really sorry, guys. Sometimes I do my y's curly, and sometimes I do them straight. I have no idea why I changed them. I don't have great mental control over that, so I apologize, okay? I wish I was consistent, but I'm not. All right, so we use this a lot when we're solving for y. Because what happens is, guys, we will want to get our equations. If it has x and y, it's so helpful to get it in y equals. Because it's easy to graph when it's y equals. So we solve for y a bunch when we are dealing with linear equations. So I'm going to give us one example right here, okay? So example 1 for solving for y. We have 3y minus 2x is equal to 9. Okay? 3y minus 2x is equal to 9. So I want to solve for y. So I need to get the y by itself. So, we're going to go through the same steps of solving an equation. Do I need to distribute right here? Nope. Do I need to combine any like terms? Nope. I do need to move my variables, though, right? I got to get this 2x out of here. How am I going to move that 2x, y'all? Well, it's not multiplied by the 2x. It's not multiplied by the 3y. We are going to move it by adding it, okay? But if I add 2x on this side, I got to add 2x on that side. Should I add 9? Should I add the 2x to the 9 to make 11x? No, because they're not like terms. So what I like to do is I line it up under something that's, I don't line it up underneath the 9. I line it up under like an invisible x so that I don't accidentally put my 9 and my 2x together. Does that make sense, guys? I want to keep them separate. So then we're left with 3y, because my x is canceled, is equal, I always put my variable first, 2x plus 9. So we have our 2x and our 9, okay? I could have also written 9 plus 2x. That's totally acceptable. But I want it to be in this slope-intercept form, so I'm going to put my x first, okay? Now is the y completely alone? Is the y alone yet? What do we got to do now? Got to divide it by 3, okay? So here's the thing, guys. If I divide this side by 3, it's going to be cancel out, and we're just going to be left with a y, right? However, I need to divide this side by 3, don't I? Okay? Now, if I divide this side by 3, 2x plus 9 over 3. That is correct, but it's not fully simplified, right? Because really, the 2x is being divided by the 3, and the 9 is being divided by the 3. So I would actually write this as 2/3 x plus, what's 9 divided by 3, y'all? 3. Okay? So my final answer, when we are solving for y, if we want to get it in slope-intercept form, would look like this. Do y'all feel okay with that? All right. Let's look at a second example. Okay? Okay, example number 2. Okay, we are going to do y. See, I just changed it. I don't know why I do that. Okay, I don't know why I changed my y's. Y minus 4 is equal to negative 3x, parentheses, x minus 3. Okay, so we need to solve for our y. But the first thing we need to do is we got to do some distribution, right? So how do we do that? All right. So we need to do our distribution. So we're going to go ahead and do our negative 3 times x is just negative 3x. Negative 3 times negative 3 is going to give me a positive 9. Nothing changed over here on the left, so I'm just going to put y minus 4 equals negative 3x plus 9. Y'all feel good about that? Okay. Next, guys, do we need to combine any like terms? Do I need to move my variables? Do I need to move my x's away from my y's? Nope, it's already away. We're good. I do need to move my constants, though, don't I? So I do need to move my constant. So what do I do here? Add 4. That's it. Okay, we want to move that away from our y. We want to get the y all by itself. So we are going to have y is equal to negative 3x plus 13. Now, do we need to remove a coefficient from the y, or are we good? We're good. We don't have to. So now, guys, that's our final answer. Y'all feel good about that? That's not too bad, right? All right. Now, I'm going to do, let's do another one. We're going to do 2 more, and I'm going to let you guys have time to work on your homework. Okay, example 3 here. We got, example 3. So we're going to do y, I'm going to change it to the curly one. Y minus 8 equals negative 1/2 x plus 4. Okay? So once again, just like example 2, we're going to need to do some distribution. Okay? So I'm going to go negative 1/2 times x gives me negative 1/2 x. Negative 1/2 times positive 4 gives me negative 2. Nothing changed over here on my left side, so we're not going to change it. Remember, I forgot to circle it. We are wanting to isolate that y. So what do I need to do to get the y by itself? I'm going to add 8, right? So if I add 8 to both sides, then we're left with y is equal to negative 1/2 x plus 6. Okay? Now what if I'm left with a negative y? What do I have to do? Divide everything by negative 1. Okay? So if you're left with a negative y over here, you want it to be a positive y. Okay? So last example that we're going to do together, I'm going to do it back up over here because it's kind of similar to this first one. So I wanted to compare the two. Okay. But it's a little bit easier. Let's see here. We're going to do, I'm going to say 4y is equal to 2x plus 16. Okay? So do I need to distribute anything? Nope. Do I need to combine any like terms? Nope. Do I need to move my variables? No, it's already away from the y, right? If it was 4y plus 2x, we'd have to move it away, but we don't have to, okay, because it's already on the other side of the equal sign. I don't even need to move any numbers. All I have to do is remove that coefficient. I literally have one step to do, right, to get the y by itself. So what do I need to divide by? 4. So I'm going to divide this side by 4. But guys, this is what so over here, I wrote it as all being divided by 4. Typically, how I write it is I do each one individually so it's easier for me to simplify. Does that make sense, y'all? Instead of doing it all divided by 4, I say, okay, 2 divided by 4, 16 divided by 4. And then I rewrite this as y is equal to 2 divided by 4x is 1/2 x. 16 divided by 4 is plus 4. Okay? So do y'all see I'm doing the same thing? Dividing everything by 3 is the same thing as dividing each term by the coefficient there. Y'all feel good about that? Okay, so these are our examples. So guys, now I'm going to give y'all some homework, and we can get started on those, and then we can, and if you guys have any questions, I will be here.